All right, so we're going to look at another example. This is, so just to clarify, this is question number 11 from your book over here on section 4.3. So this is 4.3, page 215. And we're going to look at 11. It says y equals the piecewise function 2x when 2 minus x squared, or when x is less than 1, or when x is greater than or equal to 1. So we want to find the intervals of concavity of y. Okay? So we're going to, this is my question here basically. I want to find the intervals of concavity. That means I need to find where it's concave up and concave down. So we're going to employ the second derivative test here. So the first thing you're going to do is so step 1, 4.3, it's page 215. Page 215. Thank you. So we're gonna find the intervals of concavity. We're gonna do so by the second derivative test. So we first want to find the point of inflection. How do we find the points of inflection, Miguel? How many times? Very good. We find where f double prime is, and we set it equal to what, sir? 0. Right? So if you notice here, step 1 is a little bit tricky, right? It's where it's 0 or where it what? Does not exist here. So we need to check this out here. So what's going down here? So I have a piecewise, so I have to actually get a graph of this one here to figure this out. So I have a 2x. What kind of function is this? Linear. From where? 1. So here's 1, right? So, here's 1. So I have 2x for when x is less than 1. So what does 2x look like? What's the slope? What's the y-intercept? So I start at 0, right? And then I go what? Up 2 over 1. If I go over 1, I'm hitting here, right? And it's open here because it's not equal to. And it's less than, so that means it goes this way, right? Okay, and then the next part of my piecewise is what? 2 minus x squared for when x is greater than or equal to 1. So here, it's a negative parabola. It's going down, and then what's the shift? Up 2. So basically, you have a parabola. It's supposed to start like up here, and then it does something else. To find the height of the function, you plug in the critical value. So if you plug 1 in here, you get 2 minus 1 squared is 1. So when x is 1, the height is 1. So it actually comes here. Oh, excuse me. Whoops, you're right. Good job. So this is still open. And then you have a closed dot here, and your parabola goes like this here. And you erase this part. So basically you have this over here. So now we're going to find the concavity of this function. Here we go. So if we look at this one here, so where does well, this is an easy one to ask, right? So clearly here, what is the concavity of this function? It's clearly concave down, right? Right? How can you tell? It makes the sad face, right? That's an easy way to check here. Right? Also, it's like a clown. As you can see here, the first derivative doesn't exist here, right? So therefore, the second derivative also doesn't exist where? Here. So f double prime of x does not exist at where? Because it's discontinuous. So that's our only point. Now the cool thing here is that we already know that it's concave down everywhere, right? But let's double check with the second derivative test here. You already know what's going to happen. So we're going to plug in values of 1. Values to the left of 1 and to the right of 1. Okay? So the first thing we do is, so let's pick what? 0. So if I plug in 0, But see, you see the problem here? So we're going to plug it in, and we're going to plug it into which one? The second derivative. Aha, but I have two functions. Which function is to the left of 1? So f of x is 2x. If I take the derivative of this, what do I get? What's the second derivative? 0. Right? Yeah, what's the derivative of 2? 0, right? So then this means that at 0 here, this has no, if it's 0, that means there is no concavity here. So there is no concavity for this side of it here. Yeah. So this part, so we're going to write over here, there is going to be no concavity here. And then we're going to check the right hand side of 1. And to the right of 1 is which one? So f of x equals 2 minus x squared. So what is f prime? And f double prime is what? Negative 2, which means it's what? So no matter what x is, it's always going to be negative, which means this is always minus. So that means where is it concave down? One to infinity here. So it looks like even though the function looked as though it was kind of concave down forever, we didn't nail down the definition of concavities. There really kind of has to be some type of curve to have concavity. If it's a straight line, it's not going to have any here. So the concavity, so we're going to write y is concave down from where? It's going to be from 1 to infinity. And this is the concavity of the function. Yes?
What is the